Hello and welcome to this video by Mission AI as part of our core Python programming course. In this video, I'm going to complete module 3, that is our section on collections. And the data type we're going to look at in this module is the set data type. Okay, if by chance you hear any background sounds, please excuse me, there's some construction work going on there, so there's not much I can do about it. Now, we've already seen string, list, tuple, and dictionary in our Python collections, right? The last one we're going to look at is set. Now, what exactly is a set, right? A set is a Python collection that contains unordered, unique items. So remember those two words, unordered, unique, right? So it doesn't matter which order they're placed in. The only thing that matters is the contents of the set. And the other thing is you can't insert the same element multiple times. I mean, you can do it and an error won't get thrown, but the set as such will only contain one copy of each value, right? Now, another constraint on the set object or the set data type is that it cannot contain immutable items. Now, we've already spoken about what mutable and immutable is, right? Uh, Sorry, the correction is it cannot contain mutable objects, right? It has to contain only immutable objects. So the mutable objects that we've seen so far are list and dictionary. So they cannot be contained in a set, okay, because they're mutable. The set has to contain only immutable items. So it can contain bool, float, int, string, whatever else is immutable, right? Now, in school we've dealt with sets, right, as part of our math curriculum, and we've seen union, intersection, difference, and so on. This is the same concepts apply here as well, right? Like you have these Venn diagrams, you have this intersection, you have the overall sample space, and so on. So let's look at these with some examples, and I think you'll understand it a lot better. Now, in the case of dictionary, we saw that we used curly braces, and within that curly braces, we specified key value pairs separated by a colon, right? Now, a set also uses curly braces, right? Now, the difference here is that you have individual items that are comma separated within those curly braces. So Python is like the Python runtime is smart enough to understand whether you are initializing a dictionary or a set. Because if you were initializing a dictionary, between the curly braces, you would have these entries which are key value pairs separated by a colon, right? But in the case of a set, you would have individual elements separated by a comma. And these elements would not be mutable. So you would not have a list, you would not have a dictionary. Now, if I were to say S1 equal to just curly braces with nothing in between, do you think that would create a set? I don't think it would create a set because this is the exact same way we defined an empty dictionary in the last video, right? So there is no way we can define an empty set using the exact same syntax. Python takes this to be a dictionary. So we cannot use this method. Instead, we use the set constructor, right, to initialize an empty set. Now, in this case, a set is created. In the first case, a dictionary is created. Let me just run that and show it to you. So if I run the first thing and then I print out the type of S1, it'll give us a dictionary. You can see class dict, right? That's because these empty curly braces indicate an empty dictionary, not a set. If I wanted to create an empty set, I would use the set constructor function. Now if I run this, you can see that the type of S2 is class set. So a set has been created in this case. Okay. Now we've seen empty sets, right? Now let's see how to instantiate or create a set with values. And I told you it's heterogeneous. You can have any type of values as long as they are immutable. So in this case, I'm creating a set with integer 1, integer 2, string 3, float 4.5, and boolean true. And Python lets us do this just fine with no error whatsoever because all these are immutable types. So if I print S3, it should reflect these values, which is exactly what happens here. And again, I can use the set function or the set constructor to create a set with certain values, right? And I have to pass a compatible data, like a compatible object in that constructor. Now, if I pass nothing, then it creates an empty set. But if I want to create a set with actual elements inside, then I have to pass a compatible object. And that object should be an iterable, right? So it would be something like a tuple or a list, so on. So in this case, I'm passing a tuple. And in the next case, I'll pass a list. And in both cases, we can create a set using the set constructor. So over here, I'm creating this set from the tuple containing 4 values, right? And in this case, the list contains 6 values, and I'm passing that list inside the set constructor function. So let's run this and see what results we get for S4 and S5. So S4 contains the individual elements from the tuple, and S5 contains the individual elements from the list. Now, if you look at this list, you'll see that the value 4 has been repeated twice, right? And what I told you was a set was an unordered, unique set of items, which means that there is no repetition allowed, right? So if you look here, the value 4 is contained only once in this set S5. So you can supply any, like you can repeat a value any number of times, but the set will accept it only once. But the good thing is it won't throw an error. So let's do a couple of exercises to cement our concepts about sets. Initialize a set with the values 100, 200, 30, and 40, with 30 and 40 being strings. So I'm going to say S equal to curly brackets and these 4 elements, right? I'm going to print S. I could have also done, actually no, so I could have also created a list with these values and then created S equal to set of L and print S. I could have also passed the same value in a tuple, which is with round brackets, and say S equal to set of T and then print S, right? So in all cases, I should get the same output. In one case, I'm directly creating the set. In the other cases, I'm converting from a list as well as a tuple. So let me run this, and you can see that in all 3 cases, I get the same output. Now create a set from a list containing the values A, B, C, right? So I'm going to say S equal to curly braces. Sorry, I can't use curly braces because I'm converting from a list, right? So I'll use set instead. And then I'll pass this list as the object into the set constructor. And then I'll print S. You can see that the set contains the individual elements from the list, right? Like the set can't contain a list because the list is mutable, but the set contains the individual elements from the list. So let's move on to some set operations now, right? Now, when I think of a set, like what are the things I can do with it, right? Like if I want to get some information about the set, it would most likely be how many elements are in the set. And for that, we have the len built-in function, right? I might want to add some elements to the set. I might want to remove some elements from the set. And I might want to also just compare one set with another using these typical set operations like union, intersection, difference, checking if one set is a superset of another, checking if it's a subset of another, and so on, right? So let's just go through a few examples here. So we have a list, right? 1, 2, 3, 4, 5, and 4, 5. So first we're going to create a set from this list. Okay, let me just run it here, and I'm going to print XS. So I call it XS just because it's a set from the list X, right? Now if I run it, you'll see that there are only 5 elements in this set, but the list has 6 elements, which shows that one element here is repeated, but it cannot be repeated in the set because the set contains only unique items. So the set has values 1, 2, 3, 4, 5. Okay. Now let's say I have a second set called Y, right? And the first operation I'm going to look at is find the number of elements in set XS, right? So XS has 5 elements here. So I'll use the len of XS built-in function to find the length of XS. It's 5. Contains the elements 1, 2, 3, 4, 5. Now, there are two different ways of adding elements to a set, right? One is using the add method, and the other one is using the update method. So I'm just going to rename this to ys instead of y, right? And I'm going to copy these couple of statements to add elements to a set. Just going to change it here also to ys. Now, XS is our set here, right? Which contains 5 elements, 1, 2, 3, 4, 5. And I want to add an element with value 6 to it, right? So all I need to do is call the add method on the XS object. So I say XS.add 6. Now if I print out XS, what happens is it'll add this element to that set and now show 6 elements overall. So you can see that initially it was 1, 2, 3, 4, 5, but now it's 1, 2, 3, 4, 5, 6. Now if I uncomment these two lines, right? So I had set ys and it has values 4, 5, 6, 7, 8, and these are all unique values. So the length of ys is 5. I can use, so I've already used the add method to add a single value, right? But if I want to add multiple values, I use the update method, right? And what update does is it adds values from this list that aren't already in the set. So if the set contains those values, it just ignores them. But if the set doesn't contain those values, then it inserts those elements into the set. So there were 4, 5, 6, 7, 8 already in ys, right? And I want to update it with 7, 8, 9, 10. Now you can see that 7, 8 are already present. So it doesn't bother with these two elements. But 9 and 10 get inserted because they're new elements which aren't already present in ys. So if I run this here, you can see that ys now contains 4, 5, 6, 7, 8, which were the original items, and 9 and 10 added now, right? And I can pass like anything over here. It could be a list, it could be a set, it could be a tuple, and so on, right? So I've shown you two elements to add items to a set. One of them is the add method, which adds an item, a single item to a set. And the other one is the update method, which takes an iterable or a collection and it adds the elements to the set which aren't already in the set. Now, just like there are methods to insert values into a set, there are also methods to remove values from a set, right? And there are two main methods. One of them is discard and the other one is remove. I'll tell you the difference between the two, right? Now, discard basically takes a single value and like it throws it out from the set, right? But the difference here is if the value is not present in the set, discard doesn't throw an error, right? Now, as of the last operation, we saw that ys contained these elements 4, 5, 6, 7, 8, 9, 10. And I'm saying discard 10, right? And I'm also saying discard 11, but 11 isn't present here. However, that will not throw an error. So if I run this, you can see that ys now contains 4, 5, 6, 7, 8, 9, and 10 has been discarded. And 11 did not exist, so that wasn't affected anyways. Now, another element, another method that we look at is remove, right? Now, remove also removes a single value from a set. But the difference between remove and discard is that remove throws an error if that element is not present in the set. Now, I have excess, right, which is here. And it contains only the unique values from this. And I added the value 6 to excess over here, right? So let me print excess before and after doing this remove operation, right? So excess had 1, 2, 3, 4, 5, 6. Then I did excess dot remove 6. And now I have only 1, 2, 3, 4, 5. So the value 6 has been removed. And if I do this again now, like excess of remove 6, right? Now I'm doing it at a time when this set does not have the value 6 anymore, right? So it should throw an error. Let's see if it does. And there we go. Key error 6, basically saying that the value does not exist for Python to remove it from the set. I'm just going to comment that out. And now I'm going to show you a bunch of typical set operations, right? Let me just clear all this stuff out. Actually, let's leave it there. So what is the union of two sets, right? The union of two sets is basically all the elements of set 1 combined with all the elements of set 2, right? And if there are any common elements, it doesn't matter. It just takes a single copy of them. So it's like the superset of all the elements contained in sets 1 and 2, right? So the way I do it is xs.union ys. So I had a set xs which contained 1, 2, 3, 4, 5, and I have ys which contains 4, 5, 6, 7, 8, 9, right? So xs union ys should give us the entire set of items. Like, let me just clear out most of this so that it becomes a little more clear to you. Here we go. So I've got xs which has 1, 2, 3, 4, 5, right? I have ys which has 4, 5, 6, 7, 8. So xs dot union ys is a method, right? And even if you call ys dot union xs, the result is the same. And you need to understand that neither of the original sets gets changed. What gets returned is a new set with the union. So I'll just comment out everything below this. And I'll run xs.union ys. So I'm also going to just print out ys here to show you what it was, right? So xs is 1, 2, 3, 4, 5. Ys is 4, 5, 6, 7, 8. So xs union ys is 1, 2, 3, 4, 5, 6, 7, 8, which is all the elements of these two sets combined, right? Now, if xs.union ys gives us all these elements combined, what is the intersection? The intersection is basically all the elements that are in common between these two sets. So both sets should contain these elements. So if I run xs.intersection ys, you can see that only 4 and 5 are present in both the sets, right? So XS intersection YS is 4, 5. And that's also returned as a set. Now, what is difference between two sets? The difference, like let's say set XS minus, that is difference, set YS, is basically the elements of set XS that are not in set YS, right? So I have 1, 2, 3, 4, 5 in XS, and I have 4, 5, 6, 7, 8 in YS. So the question is, what are the elements of XS that are not in YS? So it's obviously only 1, 2, 3, right? Because 4 and 5 are in common. So if I run XS difference YS, I should get 1, 2, 3, which is basically the elements of XS that are not in YS. Now, another thing, uh, another concept that you'd probably uh, understand with sets is what is a superset and what is a subset, right? Like a superset is something where, uh, like let's say I have a set A, right, with values 1, 2, 3, and I have a set B with values 1, 2, 3, 4. All the values of set A are contained within B. So B is a superset of A and A is a subset of B. So now XS has the values 1, 2, 3, 4, 5. So the question is it a superset of 1, 2, 3? And 1, 2, 3 being in a set, obviously. And the answer should be true, right? It is a superset because all these elements are contained within XS. So if I run this cell, it returns true. So XS is a superset of the set containing elements 1, 2, 3. And I've told you that if A is a superset of B, then B is basically a subset of A, right? So now the question is set containing 1, 2, 3 a subset of XS, right? It's basically the converse of this initial statement. XS is a superset of 1, 2, 3. So 1, 2, 3 is a subset of XS. And this should also return true. Now, if I'd added this, like 1, 2, 3, 7, right? Then it would be false because not all elements of this set are contained in this set. And finally, you have this thing called disjoint, right? Disjoint sets are basically sets that have no overlap. That is, the elements of set A are completely different from the elements of set B, right? So here the question is the set containing the elements 1, 2, 3 disjoint from the set containing the elements 4, 5, 6? And the answer is true. These two sets have nothing in common, right? There's not a single common element. So they are disjoint sets. So if I run this, it gives me true, which is the right answer for this. Now, if I said 1, 2, 3, 4, now 4 is there in set A, 4 is there in set B, so these sets are no longer disjoint. So now it gives me false. Cool. So that's basically a little bit about sets, right? I've shown you how to initialize a set. I've shown you how to insert values into a set. I've shown you how to check the number of elements using the len function. We've seen the difference between discard and remove. Discard doesn't throw an error, remove throws an error if the item is not present in the set. And then we've seen all the usual set operations, right? Union, intersection, difference, subset, and superset, and disjoint. So let's do some exercises now. So create a set called set1 with the values 1, 2, 3, 4, 5, right? So I'm going to say set underscore 1 equal to, in curly braces, 1, 2, 3, 4, 5. I'm going to print it out. Here we go. It's been created correctly. Now I'm going to create set2 with values 5, 6, 7, 8. Set underscore 2 equal to 5, 6, 7, 8. And I'm going to print set underscore 2. It's been created. And I told you, this is like a unordered collection of items, right? So Python can display it in any order. How many more elements does set1 have than set2? So how many elements does set 1 have? It's len of set 1. And the number of elements in set 2 is len of set 2. So I just need to do len of set 1 minus len of set 2. So print len of set 1, which gives us the number of elements in set 1, minus len of set underscore 2, which is the number of elements in set 2. So set 1 has one more element than set 2, right? Which is right. Now insert the value 6 into set 1. So I've shown you two methods here that insert an element into a set, right? One of them is add and the other one is update. Now in this case, we want to just add a single item into the set. So we'll use the add method. So set underscore 1 dot add, and the value is 6, right? So now if I print set 1, I get 1, 2, 3, 4, 5, 6. And the original value is 1, 2, 3, 4, 5. Insert into set 2 the elements of the list 7, 8, 9, 10, 11, which it doesn't already have. So I told you there are two methods to insert values into a set. One of them is using the add method, which we already used. And in this case, I want to add the elements of a list which are not already there. So I'll use the update method. So set underscore 2 dot update, and I'm going to enter this list here, right? And set 2 initially contained 5, 6, 7, 8. Now we're adding some more elements to it. Let's print out the new contents of set 2. So you can see that it contains 5, 6, 7, 8, 9, 10, 11. So 5, 6, 7, 8 were already there. So it didn't touch these two from the update statement. But 9, 10, 11 were not there. So they got inserted into the set. Remove element 11 from set 2 in a way that wouldn't throw an error if it didn't exist. Now, there are two methods to remove elements from the set, right? One is discard, one is remove. Now, the way that does not throw an error is discard. So I'll use the discard method in this case. So set underscore 2 dot discard 11, right? Now if I print set underscore 2, it'll have only 5, 6, 7, 8, 9, 10 and not 11. List out all the elements belonging to both the sets combined. So how do I list out all of this combined? I told you about the union operation, right? So let me say print set underscore 1 dot union set underscore 2. And this gives me the entire set of elements. And what I could also do is print set underscore 2 dot union set underscore 1, right? And I get the same answer in both cases. So it works both ways. A union B and B union A give the same answer. What are the common elements between the two sets? So the operation we're looking at here is intersection, right? Intersection is what gives us the right answer. So I'm going to print set underscore 1 dot intersection set underscore 2. And if I run this, I get two elements, right? There are only two elements in common. So set 1 had 1, 2, 3, 4, 5, after which I added 6. So 1, 2, 3, 4, 5, 6. Set 2 had 5, 6, 7, 8, 9, 10, 11, after which I removed 11. So it has only 5, 6, 7, 8, 9, 10. And the two common elements here are 5 and 6. Which elements does set 1 have that set 2 doesn't have? So that is the difference operation, right? So I would do set print set underscore 1 dot difference set underscore 2. And the elements of set 1 that are not in set 2 are basically 1, 2, 3, 4. Okay. And now are the sets 1, 2, 3 and 3, 4, 5 disjoint? right? So I can just type out these sets directly. 1, 2, 3 dot is disjoint, and then I type the other set 3, 4, 5, right? And the answer should be false because they do have the value 3 in common. If I were to say just 1 and 2 is disjoint with 3, 4, 5, then the answer would be true. But if I included 3, the answer would be false. So that brings us to the end of this set data type, right? Set basically is an unordered, unique item collection, right? Uh, you can add elements to it using add and update methods. You can remove elements from it using discard and remove methods. You can do all the usual set operations like union, intersection, difference, superset, subset, and so on is disjoint. Just remember, they contain only unique items. There's no repetition. Order does not matter, and sets cannot contain mutable items. They contain only immutable items. So lists and dictionaries are not allowed inside sets. And now finally we look at just the last part of module 3, which is converting between all these different data types, right? Like we already saw some basics of converting between data types in module 2, where we converted between the basic data types. Now in this case, we're going to convert between all these different collections. Now the string function, which is basically a constructor for a string object, converts variables to the string data type, right? But it needs to be a compatible type. Like for example, I told you that Python has strong typing, right? It doesn't allow operations between incompatible types. Now, if I wanted to print this message here, this is the number to track, and I wanted the value 5.5 after this. 5.5 is a float, right? I can't do string plus float. That makes no sense. So I have to convert this float into the string representation of the float first and then print it out, right? So let me just run that here. So now the message gets printed correctly, right? But if I didn't have this, for example, if I removed this string function and I ran it, it would throw an error. So I had to convert it to a string representation and then concatenate it with this other string. Now, I've already covered this in the previous module, but we can just go through it again. The int constructor function basically converts a compatible type into an integer, right? So if we had passed a float to this int function, it would just drop the decimal part and keep the integer part. If we pass a string to it, then it has to be an integer stored as a string. It cannot be anything else, otherwise it would throw an error, right? The float function similarly converts a compatible object into a float data type. Like in this case, I'm passing a string representation of a float value to the float constructor and it prints just fine. Let me just show you these two. So I'm going to print this integer, right? Which converts the string representation of 444 into an integer. But if I had passed some incompatible thing, let's say I'd passed a float, then it would throw an error because it can only convert an integer represented as a string into an integer itself, right? Similarly, I can convert 444.55, which is a string representation of a float, into an actual float, right? So if I do type of this, it should pass, it should give me class type float. And in this case, it should give me class type int. There we go. We have class int in the first case. We have class float in the second case. Now, to convert into dictionary, we can use the dict constructor, right? And I told you that a dictionary has key value pairs, right? Now, what is another way of representing a pair? It's as a tuple, right? And if you have a list of tuples, that's basically a representation of a dictionary key value pairs. So I can pass a list of tuples to the dict constructor and it will create a dictionary out of it. So let me just paste that here. So I should ideally get a dictionary which has two keys, right? Key 1, which has corresponding value 1, and key 2 with corresponding value 2. So if I print it out, sorry, I need to add this closing bracket here. If I print it out, this is what I get. And another one. Here we go. I have a dictionary with two keys and the corresponding values. Now, again, list converts a collection into the list data type, right? So if I have a dictionary, for example, with two keys and two corresponding values, and I say dictionary.values, then I'm just getting the like the if I did dictionary.items, I would get key value pairs. If I do dictionary.values, I just get the iterator of values from the dictionary, and that can be converted to a list. So if I copy this here and I paste this here, so I get a list containing 1 and 2, right, which are the values from this dictionary. So this is the list constructor function. Similarly, I can also convert a compatible data type or elements from that into a tuple, right? Using the tuple constructor function. In the first case, I'm passing a list to it and the elements of the list become the elements of the tuple. In the second case, I'm passing a string to it. So each character of the string becomes one element of the tuple. Let me run that and show you. Here we go. So the first tuple is 1, 2, 3, 4, 5, and the second tuple is string, the individual characters, right? And finally, we have the set function to convert from like a list or a tuple into a set, right? And if by chance it did contain duplicate items, those duplicate items would be thrown out and only the unique items would be kept. So I can pass either a list or a tuple, and that's completely fine. Here we go. I have the same output from both these statements. So we've seen all these different constructor functions, right? String, int, float, dict, list, tuple, and set. And that's how you can convert between different data types. Just remember the object that you pass has to be of a compatible data type. Let's do some exercises now and just cement our understanding of these concepts. Print out the message, yes, I scored, followed by the number 100. Now I can't add a string to an integer, right? So I have to convert that integer to a string representation and then concatenate them. So I'll say print, yes, I scored plus string of 100. If I print it out, this is what I get. So here I've used a string constructor. Now convert the list containing two tuples into a dictionary. I've already told you that I can use the dict constructor function to take a list of tuples as the input and convert it into a dictionary, right? And these list of tuples are basically a list of key value pairs. So I'll say L equal to this list of tuples, right? And I'll remove the and in between. Now I'm going to use the dict function to convert these into a dictionary. Say D equal to dict L, right? And I'm going to print D. So I have a dictionary with these two keys and their corresponding values. Moving on to the third exercise, convert the values of the above dictionary into a list, right? So I have D and I want to convert those values from there into a list. So I'll say L equal to list of D dot values, right? D dot values gives me the values from the dictionary and I'll then convert that to a list. So if I run this and I print it out, you can see that I have 1, 2, which are the values from here. Now convert the above list into a tuple, sorry. So I'm going to say T equal to tuple of L, right? Now it's a compatible type, so it'll accept it and then I'll print it out. There we go. Let's have the same elements in tuple form now. Create a tuple containing all the characters of the string data types. So I'm going to say S equal to data types, T equal to tuple of S and print T, right? So now I have each character of the string as an element in the tuple. Now I want to convert this above tuple into a set, right? So what you remember that a set is set contains only unique items. So if there are repetitions here, those get thrown out and only the unique items are kept. So set underscore 1 equal to set of T, which is the tuple, right? You say print of set underscore 1. So you can see that only the unique elements have been retained and the duplicates have been thrown out. Or rather, only one copy of each element is retained, right? The second, third, fourth, fifth copies are all thrown out. Now, the last thing I want to take you through is two really important commands, the dir command and the help command, right? Uh, there's no way you can remember everything that you need about the Python language, right? If you go to one section, you'll forget something from the other section. So if you need to access the documentation, then these two functions are built-in functions that help you do that, right? Now the dir function, it's like a short form for directory, right? It lists out all the attributes and methods of the variable x, or rather of the object that the variable x points to. So for example, let's say I have a string, right? And I want to understand what are the properties of a string that I can access and what are the different methods of strings that I can access. Then I will use the dir function. So let me just create a new thing where I'm going to run the above code and I'm going to say I want to list out all the attributes and methods of a string object. And it could have been anything. Like in this case, I've initialized an empty string. Let me run it. So it shows you all these different methods, these attributes, and these things with double underscore, they are called dunder methods. Okay, that is double under. And we'll explain what those are in object-oriented programming. But for now, we just need to know that all the methods and attributes are exposed here if we use the dir function. Like for example, when we covered strings, we saw is alpha, is num, index, is upper, and so on, right? So all those are exposed here. Now you can even say string with the value test and you'll get the same output. Basically, any object of type string that you pass to the dir function will give you all the attributes and methods of that string object or any string object. And the same thing works for other data types as well. Now, what if I wanted to, like, for example, what if I wanted to check out what attributes and methods are there for lists? So I can just pass an empty list, right? And here you now have all these list methods like clear, append, copy, count, all these stuff we've seen in the list video. If you wanted to do it for dictionaries, then you would pass curly braces, right? And we know that this is an empty dictionary and not a set. Now, if we wanted to do it for a set, we could have done 1, 2, 3. And now all the set methods would show up here, difference, intersection, disjoint, and so on. If we wanted to pass it for a tuple, we would do round brackets and say 1, 2, 3. So now you have all your tuple methods. So that's how you would get information about the attributes and methods of a particular object or a data type, right? Now, if I want to get detailed documentation, like this is just the list of attributes and methods, but if I wanted detailed documentation about an object, like proper Python documentation about either an object or a method, then I would use the help function, right? So I've already used the dir function. Let me use help. Now, let's say I want to look at the entire documentation for Python. It says help on the class string in the module built-ins, right? And this is basically part of the Python standard library. So this class definition, all the methods and all the code underneath, it shows you that, right? So that's how I get detailed documentation about the string class. Now, if I wanted to get documentation about a specific method, then I would say, like for example, string.isAlpha, right? So I would say dot is alpha, okay? And I would run this. Remember, when you look for help here, don't put that open and closed round brackets because that is when you're actually calling the function. If you just want to refer to the function, don't add these brackets, okay? And here it shows you, right? Help on the built-in function is alpha, and it tells you what you need to know. So that's how you use the help function. You can say just help of an object and it tells you the entire documentation of that object type. Like in our case, it's a string. Or you can also say object dot method without those open and close brackets, and it'll give you the documentation for that particular method. So let's do a bunch of exercises here. We're right at the end of this module. So just keep going for another 5 minutes. Get a list of all methods possible on the list data type, right? So I want a list of all the methods. So that means I should be using the dir function. So print, actually not print, just dir of list, right? And I can just pass an empty list. Let me say enter, and I get all these different attributes and methods, right? Now get detailed documentation about the dictionary class. So in this case, I'll use the help function because that's what will give me the detailed documentation. So I'll say help of dictionary class, right? So I just need to create an empty dictionary here and run it, control enter. So I get entire help on the dict object. And finally, get detailed documentation about the join method of the string class. So again, I'll use the help function and I'm just going to create an empty string here and I'm going to say dot join and not dot join like this, but dot join without those brackets. Okay. And if I say control enter, I get help on just this method of the string class. So you basically know how to get help if you need, right? You can list out all the methods and attributes, and you can also check out the documentation for a particular class or object type. And this is how you use dir and help respectively. And before that, we've seen how to convert between different data types using their constructor functions. And before that, we saw how to uh, create and process the set data type and objects of that data type. So this brings us to the end of module 3. It was a gigantic module. Congratulations for following all this way. Please do all the exercises. I think it will give you great perspective and make you very proficient in Python collections. Now, in the next module, we're going to look at conditional logic. So if else and also looping, right? For loop and while loop. See you there.